MCV4U1 Chapter 4, Session 6. In this session, we are working on questions from page 178 and 179 of the textbook. 4.2, Exercise 2. For the function y equals x3 minus 6x2, explain how you would find the critical points, and part B, determine the critical points for y equals x3 minus 6x2, and then sketch the graph. To find the critical numbers, we take the derivative of the function, set the derivative equal to 0, solve it for x. Then evaluate the original function for the values of x and determine the critical points. Derivative of y equals x3 minus 6x2 is y prime equals 3x2 minus 12x. 3x is a common factor. If we set it to 0, x would be 0 or 4, critical numbers. Plug in 0 into the original function, we have 0. Plug in 4, we have 64 minus 6 times 16, which is negative 32. X and y prime at 0 and 4, derivative is 0. Less than 0, derivative is positive. For between 0 and 1, derivative is negative. And for more than 4, for x between 0 and 4, derivative is negative. And for x more than 4, it is positive. The graph of the function is a cubic function. The maximum point is 0 and 0. And the minimum is 4 and negative 32. The x-intercepts on the graph of the function are 0, 0, and 6 and 0. Question 3, part B. Find the critical points and determine if it is a maximum or minimum. Derivative of f of x equals 2x over x2 plus 9 is 2 times x2 plus 9 minus 2x times 2x, which is negative 2x2 plus 18 over x2 plus 9. If we set the derivative to 0, the numerator would be 0. X is going to be either plus 3 or minus 3. If we draw the sign chart for the derivative, at minus 3 and 3, derivative is 0. Before negative 3, derivative is negative. Between 3 and negative 3, it is positive. And after 3, it is negative. Therefore, negative 3, and if we plug negative 3 into the function, we get negative 0.3 approximately is local minimum. And if we plug in 3 into the function, we have 0.3, which is local maximum. Notice the function is an odd function. F of negative x and negative f of x are equal. So if we calculate f of negative 3, f of 3 is opposite of f of negative 3. Next question, question number 7. Again, we are looking for critical points and see if it is maximum or minimum. The derivative of f of x equals 1 over 3x3 is x2, minus the derivative of 1 over 3x3 is x2, the derivative of minus 9x is minus 9, therefore derivative of f of x is x2 minus 9. If we set the derivative to 0, we'll see x is negative 3 or positive 3. Then we draw the sign chart for derivative, increasing, decreasing, and increasing. We find f of -3 and f of 3, and then we roughly sketch the graph of the function. The function is 20. At 3 it is -16. One thing that I have to emphasize that in this part we are just practicing rough graph, not curve sketching. The graph is increasing, decreasing between -3 and 3. The x is -3 at this point and the y is 20. And here we have 3 and 16. Next question is question number 10. Determine the values of A and B, A, B, and C such that the graph has a relative maximum at 3 and 12 and crosses y at 0 and 1. It has a relative maximum at 3 and 12. Therefore, 3 and 12 is a point on the graph of the function. That means when x is 3, y is 12. Because it is maximum of the function, x equals 3 is a critical number. That means derivative of the function would be 0 when x is 3. And also, the y-intercept is 1. That means when x is 0, y is 1. We have 3 equations, 3 unknowns. When x is 0, y is 1, implies that c is 1. We're plugging 3 and 12 into the function, and 3 and 0 into the derivative. We deal with the system of equation. We solve the system of equation and we find a and b. From the second equation, b is -6a. Plug into the first function, the first equation, and find a. Then use the fact that b is -6a and find b. Last question is question number 13. Find the values of a, b, c, and d such that g of x equals ax3 plus bx2 plus cx plus d has a local maximum at 2 and 4 and the local minimum at 0 and 0. First of all, g of 2 is 4. G prime of 2 is 0. 2 and 4 is a maximum. The coordinates of the point satisfies the equation. That means g of 2 is 4. G prime of 2 is 0 because 2 is a critical number. G of 0 is 0. And g prime of 0 is also 0. X equals 0 is a critical number. From the last two equations, we get c and d equal to 0. The derivative of the function is 3ax2 plus 2bx plus c. From here, d is 0, then c is 0. G of 2 equals 4. That means 8a plus 4b equals 4, or 2a plus b equals 1. G prime of 2 equals 0. That means 12a plus 4b equals 0. 3a plus b equals 0. A system of equation. By solving this system of equation, we have a equals -1 and b equals 3. Therefore, a is -1, b is 3, c is 0, and d is also 0. Thanks for watching.